Okay, so now I want to talk a little bit about index sizes. As with other databases, with MongoDB, it's very important that we're able to fit what's called the working set into memory. So the working set is the portion of our data that clients are frequently accessing. As you might imagine, a key component of this is our indexes. For performance reasons, it's essential that we can fit the entire working set into memory, because going to disk for data is a time-consuming operation, and performance will degrade significantly if for frequently accessed data, we have to go to disk regularly. Now, this is especially true with indexes, because if in order to search an index, we first have to pull it from disk into memory, we lose a lot of the performance benefits of having the index in the first place. So it's especially important that our indexes fit into memory. So let's look at how we can measure the size of our indexes as a means of, say, estimating the amount of memory we'll need for a MongoDB deployment. Okay, so let's take a look at our students collection. We have individual students, classes, and the scores in this collection. There are 10 million records here. So first, let's take a look at what indexes we have. Okay, and we can see that in addition to the primary index, we have a secondary compound index on student ID and class ID. Now, if we want to see the size of our indexes, we can use the stats method. So we call the stats method on the collection of interest, and here we can see the total index size. And this is also broken down for us into the individual sizes for the two collections that we have. There's a shortcut method for this as well, which gives us just the total. So from this, it looks like each index we have is adding 300 megabytes to our total index size. And of course, this has an impact then on how much memory our working set requires. Now, with the release of MongoDB 3.0, we've introduced the WiredTiger storage engine. One of the key features of WiredTiger is that it supports a few different types of compression, one of which, called prefix compression, allows us to have smaller indexes. So that last example we looked at was against a MongoDB running the mmap v1 storage engine. Now let's take a look at index sizes for a 3.0 server with the WiredTiger storage engine, and in particular we've got index prefix compression turned on. Okay, so let's launch a shell and connect to that MongoDB. That one's running on the default port. So I have exactly the same data set loaded here, again 10 million records, and I've got the same indexes as I had in our last example. So now let's take a look at the index sizes here. And we can see that our total index size here is just under 200 megabytes. So rather than 300 megabytes each, our indexes are something on the order of 100 megabytes each. Now, I should also say that this compression comes at the cost of CPU, and it really depends on your data set as to whether or not you can take advantage of something like prefix compression. But it's something to be aware of and something I wanted to show you here. I'll also just briefly point out that with the WiredTiger storage engine, the stats output looks a little bit different. In particular, we've got this WiredTiger document that reports on a bunch of stats for that particular storage engine. So again, pay attention to the size of your indexes. Make sure they can fit in memory so that you can realize the full performance benefits.